All right, so I need to talk about the coupling coefficient here, which basically tells me how well two coils are coupled. Let's say I've got a coil L1 here and a coil L2 here, and I'm interested in the basically magnetic coupling considerations for this circuit in LT Spice. So basically when we draw these circuits by hand, let's just go by hand here, we're going to be typically given, I could give you either, but the textbook problems particularly, they're going to give you, oh my gosh, sorry, I'm just a mess. They're going to give you the mutual inductance between these two coils, M, okay? You'll notice that I'm writing M now instead of M12 or M21. That's because for linear circuits, which is what we're dealing with in this class, M12 and M21 are equal to each other, and so we end up just calling that inductance M, the mutual inductance of the two coils, okay? So doesn't matter the size of the inductors, doesn't matter the currents, etc. As long as the system is linear, energy considerations basically force this constraint. Okay, so the mutual inductance from this point forward, we're just going to call it M, and it's just the mutual inductance between the two coils. So we've already abstracted away a lot of those details from the first couple videos, the derivations. And so by hand, what we're going to see a lot of the times is that you're given the mutual inductance M, and you will not be able to use the mutual inductance M in LT Spice. Instead, in LT Spice, this is called L1, and I'm going to make an LT Spice video about this, of course, but in LT Spice, it's a little bit different because what LT Spice wants is it wants the coupling coefficient. And so what you write in LT Spice is you write K, or you can number the K. It could be K1 or K2 or K whatever you want it to be. Sorry, it keeps looking like an R. And then you tell it what two inductors you want to link. So in this case, it would be L1 and L2. And then you give it a value between 0 and 1. Basically, 1 is perfect coupling. It means that no energy is lost at all. They're perfectly magnetically coupled. And 0 means they're not coupled at all. Okay, so writing nothing would be equivalent to a 0. And then you can pick any value in between 0 and 1. So if you wanted a coupling coefficient of 0.5, for example, you could write that in LT Spice just like this. And now if we know the values of the K and L1 and L2, we can determine the mutual inductance, and vice versa. We can determine K if we know the values of the mutual inductance in L1 and L2. So if I give you a circuit like this that has a mutual inductance and then the two self-inductances of the coils, you throw those into this formula right here, and you'll get your K value that you can use in LT Spice. If you were given, K, two coils, names, and then the coupling coefficient, you can throw them into this equation here, and then you can determine the mutual inductance so that you can solve the circuit by hand using the methods that we're going to cover in these next couple of videos. Okay, so just wanted to talk about the coupling coefficient real quickly. In the next video, we're going to talk about the dot convention, which I haven't drawn on my coils just yet, but if you notice, these coils have these red dots here and here. The first circuit that we showed had the same thing. You're probably wondering what those are. We're going to get into talking about what those are, why they're very important for these types of circuits, and we will talk about those in the next video. So let's go ahead and end this video, and we'll see you guys in the next one.